Something strange is happening to the Earth's magnetic field's tail. Yeah, did you know that the Earth had a magnetic tail? Hello, listen to this. You may not know this. The Earth's magnetic field has a tail. As the sun's solar wind slams into the planet, it leaves behind a sort of long shadow that trails out of our planet's wake. Scientists call the magnetic tail appropriately the Magnetotail. Would you like some Magnetotail? Hello. Typically, the Magnetotail is strewn with magnetic storms. For the past several years, though, scientists have known a mystery in the Magnetotail, a missing storm. They have found a signature of a storm, but no storm to actually go with it. So NASA's Magnetospheric Multiscale mission, MMS, is now on the case. Well, way to go!
Right on. So I think I'm at month 5. Got this plugged in the garage, plugged in next to the breaker box, and it keeps saving me money. And you can save money too. All you got to do is buy one, plug it in next to your breaker box, and let it do its thing. It turns green, the light turns on, and it basically cuts down on dirty electricity, and it also helps save your electronics and your appliances from dirty electricity, and it helps lower your electricity bills, which is the main point, and it's up to 65% off if you go to don'twastepower.com, order 2 or 3 or 4 or more, and let's get back to the podcast. Don'twastepower.com. That's don'twastepower.com.
The MMS consists of 4 satellites. They're all launched at the same time via an Atlas V rocket in 2015. And since then, the quartet has been studying Earth's magnetosphere, Magnetopause, the frontier of the region dominated by the planet's magnetic field. The magnetopause is constantly aflame with magnetic reconnections, which refer to when the lines that make up a magnetic field come together, break apart, then rejoin, creating brilliant flurries of heat and kinetic energy. These reconnections, if they happen in Earth's atmosphere, can create auras, like many of us saw just last week. Now, these flurries, these substorms, is what they're called by scientists. Now, in 2017, the MMS spotted the trademark magnetic reconnection of a substorm and no actual substorm to go with it. A substorm should come with violent electric currents and magnetic field fluctuations, but the MMS traces neither of them. Here's a quote. "We have not looked at the movement of the magnetic field lines on a global scale, so it could be that this unusual substorm was a very localized occurrence that MMS happened to observe," said Andy Marshall, a postdoc at the Southwest Research Institute, in a statement. "If not, it could reshape our understanding of the relationship between tail-side reconnection and substorms." So for the next year, MMS will measure magnetic reconnections and Earth's real magnetic field, while scientists on the ground conduct simulations of the magnetic field to understand how it behaves. By comparing the two, scientists hope to solve the mystery and better understand the precise relationship which the reconnection between the reconnection and the events they cause. It's possible that significant differences exist between the global Magnetotail convection patterns for substorms and non-substorm tail reconnection, Marshall said. Cool. Well, here's the original paper. This is the Southwest Research Institute, SWRI, investigating unusual substorm in Earth's Magnetotail. I love that. In Earth's Magnetotail. Oh, yeah. Using MMS data. So this is just a few days ago. The Southwest Research Institute is investigating an unusual event in the Earth's Magnetotail, the elongated portion of the planet's magnetosphere trailing away from the sun. Using data from NASA's Magnetospheric Multiscale mission, which is the MMS, SWRI scientists are examining the nature of substorms, fleeting disturbances in the Magnetotail that release energy and often cause auroras. Now, their launch was in 2015. The MMS spacecraft have been studying and surveying the magnetopause, which is the boundary between the magnetosphere and surrounding plasma, and for signs of magnetic reconnection, which occurs when magnetic field lines converge. They break apart, reconnect explosively, converting magnetic energy into heat and kinetic energy. So in 2017, the MMS observed signs of magnetic reconnection in the Magnetotail, but not the normal signs of substorm that accompany reconnection. such as strong electrical currents and perturbations in the magnetic field. That's very interesting. Then it goes on to say, we want to see how the local physics observed the MMS affects the entire global magnetosphere, said SWRI's Dr. Andy Marshall, a postdoctoral researcher. By comparing that event to more typical substorms, we are striving to improve our understanding of what causes a substorm and the relationship between substorms and reconnection. During the one-year project, SWRI will compare in situ MMS measurements of reconnection affecting local fields and particles to global magnetosphere reconstructions created by the Community Coordinated Modeling Center at NASA's Goddard Space Flight Center using the University of Michigan Space Weather Modeling Framework. So basically what they're saying is they're going to be doing models, computer models here, and they're also going to compare that to the real data that they're picking up in space. And I think that's pretty cool. They can measure the differences, they can figure it out, and it would be nice if they could share it all with the public. We'll see. It's possible that significant differences exist between the global Magnetotail convection patterns for substorms and non-substorm tail reconnection, Marshall said. We have not looked at the movement of the magnetic field lines on a global scale, so it could be that this unusual substorm was very localized occurrence that MMS happened to observe. If not, it could reshape our understanding of the relationship between tail-side reconnection and substorms. The MMS is the fourth NASA Solar Terrestrial Probes Program mission Goddard Space Flight Center built, integrated, and tested for the MMS spacecraft, and it is responsible for overall mission management and mission operations. The principal investigator for the MMS instrument suit science team is based at SWRI in San Antonio. Hey, San Antonio! Science operations planning and instrument commanding are performed at the MMS Science Operations Center at the University of Colorado's Laboratory for Atmospheric and Space Physics in Boulder. If you'd like more information, visit Planetary Science, and I'll leave the links in the video description box. Wow. So the Earth has a magnetic tail. Hello. This is interesting. This is Science Alert. Is the Earth's magnetic field on the verge of flipping over? An expert explains. We need the experts. We need as many as we can get. The Earth's magnetic field plays a big role in protecting people from hazardous radiation and geomagnetic activity that could also affect satellite communications and the operation of power grids. And it moves. Scientists have studied and tracked the motion of magnetic poles for centuries. The historical movement of these poles indicates a change in the global geometry of the Earth's magnetic field. It's our force field. It may even indicate that the beginning of a field reversal, a flip between the north and south magnetic poles. Then the article goes on to say, I'm a physicist who studies the interaction between the planets in space. While the north magnetic pole moving a little bit isn't a big deal, a reversal could have a big impact on Earth's climate and our modern technology. But these reversals don't happen instantaneously. They occur over thousands of years. This right here, what you're looking at, is the north magnetic poles, which were observed from 1831 through 2007. Those are the yellow squares. And it looks like the modeled pole locations are from 1590 to 2025. Those are the circles progressing from blue to yellow. How are the magnetic fields generated around Earth? By moving electrical charges, a material that enables charges to easily move, and it is called a conductor. Metal is one example of a conductor. People use it to transfer electric currents from one place to another. The electric current itself is simply negative charges called electrons moving through the metal, and the current generates a magnetic field. So you have layers of conducting material, which could be found in the Earth's liquid iron core. Currents of charge move throughout the core, and the liquid iron is also moving and circulating in the core. And then these movements generate the magnetic field. Earth isn't the only planet with a magnetic field. Gas giant planets like Jupiter have a conducting metallic hydrogen layer that generates their magnetic fields. Cool! So you've got movements of conducting layers inside planets, which result in two types of fields. Then you have larger motions, such as large-scale rotations with a planet. This leads to a symmetric magnetic field with a north and a south pole, similar to a toy magnet. Then you have conducting layers, which may have some local irregular motions due to local turbulence or smaller flows that do not follow the large-scale patterns. These irregularities manifest in some of the small anomalies in the planet's magnetic fields, or places where the fields deviate from being a perfect dipole field. Now, these small scale deviations can also lead to larger changes in the large scale field over time, potentially even completely reversing the polarity of the dipole field, where the north would become south and vice versa. So you have designations of the north and the south on the magnetic fields, which refer to their opposite polarities. So if we were to have a collapsed magnetosphere, especially with the sun heating up, with the sun turning, I mean, we're going back into a solar maximum, right? So we've got a solar maximum, a weakened magnetosphere. If the poles were to flip, the magnetic fields weakened even more. Although, like, let's look at what recently happened. We've recently had some pretty substantial solar flares that have hit Earth, X-class solar flares, massive sunspots, and the majority of the communications stayed up. There were some radio blackouts for a little while in certain areas, but overall, it seemed to do really well. So I think that on a technological scale, we're doing a fairly decent job keeping the communication sector in play, even with some pretty substantial solar storms. However, if there was a complete collapse of the magnetosphere, it would probably be quite detrimental. I mean, you know, I was going back and I was looking at some of the podcasts and the articles from like 5, 6, 7 years ago. And do you remember when there were news articles coming out describing like roofs melting, roads melting, tires melting on cars? People were complaining about getting sunburnt faster. Like I read so many people's comments about how they used to spend hours in the sun and they felt great. And now they spend minutes in the sun and they just get baked. They get cooked, metaphorically speaking. So that, in my opinion, theory could have been caused by certain locations in the magnetosphere that were weakening even more. You had these pockets which allowed for more radiation exposure and more cosmic radiation from the sun is a possibility. So I don't know. And also, if you want to watch, so I've had several emails where people are like, Rex, what happened to all your podcasts, man? We had about 4,500 videos on YouTube. I've taken the majority of those down to make sure that everything stays smooth as possible because, you know, we like YouTube. And most of those, if not all of those, are available at leakproject.com. And we're uploading a bunch of those onto our Patreon. So if you want exclusive content, if you want unedited, uncensored, ad-free content, you can check us out over on Patreon. You can become a Patreon for as little as $1, and your contributions greatly help us here. Yes, we're in the garage, but doing podcasts all day, the amount of time and research and all the places that I have to go personally to do the research, it isn't cheap. So I really appreciate your support, and have a beautiful day, everybody. Thanks for watching. Hit the bell for all notifications here on YouTube. Hopefully you'll get the notifications. Check back daily just to be on the safe side. Be excellent to each other and be the change you want to see. Oh yeah, and be prepared, not scared. Halo. Yeah,